Everybody, happy exam review day. I am going to give you just a quick little 5-minute video about the average value of a function. All right. So we have here average values of functions. Like the average rate of change of a function f, we can define the average value of a function over the interval a to b as the following. So we're using this symbol here, f_av, to mean the average value of the function, average value of the function over the interval a to b as this quantity. So if we're talking about the average of numbers, say x1 plus x2 all the way up to xn, the average is we add up all the numbers and divide by n. Okay, so this average, let's call it x bar. This number is the only number that if we add it up n many times, we get the same sum. So for instance, let's look at this list of numbers: 6, 7, and 8. Okay, the average is 7 because we have 6 plus 7 plus 8 over 3 is 7. And so if I replace every single one of my numbers in the list with 7, we get the same sum, which is 21, which is the same as 6 plus 7 plus 8. So this description here I don't really agree with here. But we're going to get the same sum if we replace every element of our list of numbers with the average. And so the way we want to think about the average value is going to be the average height of the rectangles in our Riemann sum. So what that means is if we were to replace every rectangle's height with this number, f average, I guess we're doing lowercase there, we get the same sum, right? We get the same total area. That's the big idea. So let's look at a picture. So here, if we look just at the red right now, so let's look just at the red. This is a function whose name is f. I claim that there is some y value, which we're calling f average. I claim that there is some y value such that the area on the left is the same size as the area on the right. What I mean is this area is the same as this. Okay, I've drawn this picture specifically in that way to be able to get these little areas to be the same. But my claim to you is that you can do that with any kind of function, right? Like let's say our graph looked like that from A to B. Maybe the average value is like something like this. something like the middle point where from here to here, this area right here is something equivalent to like this. Maybe we got to scooch it over a little bit. Something like this area is about the same as that area. Okay? But the point here is that if I were to replace the height of all of the rectangles in my Riemann sum, right? Like let's say my rectangles look something like this. Something like that. Maybe actually these ones. Yeah, like this. So if I were to replace the heights of all of those rectangles with actually this number, then I would get the same sum, which makes a lot of sense because the way that we've chosen f average to be this middle point is gonna, the area above this midline is gonna be kind of the same as the area below. I don't know why it's erasing. Okay, this is having a little trouble. So the big idea here is that the area under F, which I'm going to draw here in pink. So this area under F is the same as this area here of the rectangle formed where the height of all the little rectangles is the F average. And that is kind of highlighted by this area above being the same as the area below right here. So what we have found is that the area under the curve F from A to B, that was the pink, is going to be exactly equal to the area of the green rectangle, which is length times width, which is this thing is B minus A in width, and the height is this y value, F average. And so if we want to get F average by itself, if I don't write the AVE too low, or if I don't write it low enough, it looks like fave. So the average function output is equal to this integral divided by B minus A, which is the formula that we have over here on the slide. So there is a worked example right here. All you got to do is plug it into the formula now that we have it. So this is A, this is B, 1 over B minus A, integral from A to B of the original function put into there. Not too difficult. And we'll end with this mean value theorem. If f is continuous on the interval a to b, then there exists some number c such that f achieves that average. Basically, what we're saying is that the average is achieved in this interval. So c is somewhere between a and b such that the output of the function f when the input is c is the average value, or you can think of it as the favorite value, fave. And the last line right here is just rewriting this, just multiplying both sides by b minus a. But actually, I think it's better to start here and come here, right? This is the picture that we had from the previous slide. Up here we had Yes. Well done, everybody. Good luck studying.